Well, hello everyone, and welcome back for a bit of fun on this Friday. At least I'm hoping this will be fun. Let's figure out all of the usual audio thingies. Let's get rid of the visuals there in the beginning. So, do we have anyone in the stream? We have a few people in the stream. Welcome, welcome, welcome. Usually my streams are sort of like they start very kind of slow, and then I just get more and more followers until I I eventually have to end. Let's see what is the trajectory today. So let's make sure I have everything built here. Does look like I have. Yep, that looks good. Let's see if we can run the game. So today is Friday, and I figured I want to do something a little fun today to sort of close out the week, a pretty busy week of work on Traction Point, and I want to do something fun. Hey Budget Jim, welcome to the stream. What's going on? So, as a few of you might know, I'm working on mod support for the game already at this point, even though the game is not out yet. Working on mod support because I believe that mod support is going to be one way that we're going to have some longevity for the game. So we have this flying vehicle sort of thingy here, jetpack scout. What is the master volume, by the way? Master vol, it's 0.6. It's probably lowered in the main menu, I'm thinking. Yeah, do let me know, by the way, if the audio levels aren't good. Yeah, okay, we have it set to 60 here, so that's why this audio master vol thing reports here in the console as well. That's good. It's probably better to not have the game scream at us while we are streaming. So yeah, we have this guy here. The flying scout, which is a fun little thing to mess around with. It completely breaks the campaign of the game. Takes away all the challenge campaign, but that's fine because we also have the sandbox mode, and so I'm hoping to make it very easy to make new stuff for the sandbox mode. New vehicles, new gameplay features, even new levels, complete with scripting and everything, should be possible to do eventually without touching the main game. So I'm hoping to put all of that in Steam Workshop, of course, for you guys to play around with, or open up the game to Steam Workshop rather, so that you guys can actually build that sort of stuff. And one thing that has been requested a few times over the years, because yes, it's been years already, is a first-person mod, a way to play this game from first-person view, from inside this vehicle, right? So basically, like, place the camera in here. There's really nothing in here in this inside of the car, because you're not really supposed to do, you're not really supposed to go here. But we can make a first-person mod, right? Place the camera like here or something like that. Except the vehicle's a bit slanted, so it doesn't really look all that all that good, but you get the idea. And then you could play it from a cockpit view, essentially. I don't know if that is gonna make sense for all of the vehicles. To be honest, I'm kind of thinking that this mod might be a little bit of a throwaway sort of thing, but it's actually a pretty good thing to have, you know, a few mods that you can play around with and test the game with to make sure that the mod system actually works with multiple mods, right? I've only ever tested this thing with this one mod, this Flying Scout mod, which is here. You can see we have a list of things, but we only have one mod here. So let's make another one. Let's make another one, and let's make that be a first-person mod sort of thing. That could be a pretty fun little thing. It's probably not going to be like a whole lot of code, but a few new sort of things that I haven't done before. So we'll see how that turns out. Righty-o. So I did write some notes for myself here, how this could actually kind of work. So hopefully it shouldn't be super tricky to do. So like the sort of spec that I wrote for myself is as follows. Let's see if I can. There's the launch. Let's go to take that away. I think we're gonna try it out with the refinery level. It just has more space to drive, right? So in the game, you have this concept of an avatar. So we can spawn in a whole bunch of vehicles here. We can put a mother there. We can put a flying scout. It's right there. We have some more obscure vehicles like the gripper, and some of these, like the test vehicle, which is like the very first vehicle that I ever did for the game, right? If you want to have a cockpit view of sorts, then it's going to be different for all of these vehicles, right? Because we're going to want to put a camera somewhere in the local space of the vehicle, and then we're going to want to move the camera around with the vehicle, right? So if the center point of this vehicle is here, we're gonna want to maybe move it up like maybe half a world unit, not even that, maybe like 0.2 world units and forward 0.2 units until you get to about here. While for the mother vehicle, like if the center of the mother vehicle is somewhere around here, we're probably moving it like 10 world units or something. Maybe not 10, but 5 world units forward and a couple of world units up to get you know, here. Rip. Something like this, which looks kind of vaguely like some sort of AT-ST or AT-AT view from like Star Wars or whatever. I think this vehicle is going to be completely impossible to drive from a first-person view. But I'm thinking like these smaller vehicles, in particular the Scout, this guy. This guy could be kind of interesting. Or I should say, in particular, this guy, right? Because this guy can fly. So let's concentrate on the Scout, on the two different kinds of Scout. So we put the camera here, and that means, you know, we need to have different sort of local offsets for the camera. So we essentially need the mod needs to know, okay, what kind of vehicle is this that you're driving, right? And remember, we don't want to touch the game code at all here. We want to do it completely in mod code, so that
it can just be like a fun little thing that you can install into your game without having to actually like break the main game. I really don't want to do anything in the main game for this sort of thing. Partly because I want to see how how flexible the actual like mod SDK is at this point. And if we run into some issues, then we're gonna have to actually fix them. But yes, so the spec for the mod is essentially as simple as whenever we change the avatar, so basically the avatar is like your vehicle in this case. The avatar is like technically is the game object that represents the player in the world, and that game object can be a vehicle, it can be a character, it can be a freaking rock. If you have a game where you play as a rock, doesn't really matter. It can even be something that doesn't really have like a physical manifestation. The engine doesn't care about that. The engine just wants to know which object is the avatar for a given player, and we can hook into the engine to receive messages when the avatar changes for a particular player, right? So when we drive up to this vehicle here, and it says press Y to switch vehicle, like this, a bunch of things happen in the game and in the engine, and one of those things is a message that gets sent to notify everyone that's interested in that sort of thing, that hey, we've now switched the avatar to this guy rather than this guy, and then we can switch back, of course. So that place would be a pretty good thing to hook into for this kind of first-person camera. So we want the mod to receive the message when the avatar changes. When that happens, we probably actually create a completely new camera for the first-person view, right? And we attach it to the vehicle, and then we make that camera the camera that is actually used to render stuff. In my head, that is all that we need to do, right? That should provide us with a nice first-person view. So I'm just gonna go ahead and get started with that, and I'm gonna do it essentially by copy pasting the actually slightly more complicated Flying Scout mod. So here we have actually two folders. This is the mod folder. I'm actually, like next week, I've reserved some time to figuring out Steam Workshop, so I'm hoping to actually have Steam Workshop integrated pretty soon. It's not integrated yet, and so for the time being, we have to basically like manually copy our mods into this app data roaming trampoline mods folder for the game to actually pick them up, right? But eventually I want these things to be installable through Steam Workshop. But here we have Flying Scout. We also have settings, and this is just here's some earlier test FP camera. Sounds kind of similar to what we're doing today, right? Yeah, I had an earlier test just to make sure that I can actually like run multiple mods by just copy pasting Flying Scout, but I didn't actually write any code in it. I figured that is something that could be kind of fun to do on stream. So yeah, we're gonna do the same thing again. Setting has like a list of enabled mods, Flying Scout, and then also allow unsandboxed mods, which is set to true. Which actually we might need to have it unsandboxed. We'll see when we get to that point. So this is essentially where we want to like put our mod, right? We have a WebAssembly module, and we have a pack file, and then we have a mod.json file with some information about the mod itself. These 3 files are then read by the game, and we can actually use the mod for things, right? And so then we have this other folder, and this is essentially like the work folder. So we have a build folder that contains the exact same thing for the Flying Scout. We have a code folder, and this is what we're going to mess around with today. It contains all the code for the mod, and then we have a data folder which produces the actual data for the Flying Scout. I don't think we're going to need any data for this. I think this is going to be purely a code mod. Alright, so we're gonna basically copy paste, well, most of this stuff actually, probably, and then we're gonna get started. So Zig cache and Zig out, these are generated by the Zig system, the Zig compiler. We don't need those, or rather they will get recreated for us. Let's see here if we do so here we have the Flying Scout mod, like this. So we have some code here. I don't think we will need any components either. I think we can handle this all just completely in the mod controller. The entire logic for this first person mod can be contained in this. So here we have a Flying Scout mod controller. The mod controller is essentially like the main object that your mod creates, and it manages the lifetime of the mod. So you can see here that we have some init, dinit, and there's a special function called post init, but these are like essentially like constructors and destructors. We have on app startup, and then we have a bunch of other things. So you can hook into like when the client ticks, when the server ticks, when the client updates. So essentially like renders frames. Before app shutdown, on server created, before server destroyed, and then some angel script business. So things that you can declare here, and they will get called at different points of the program, right? So like an object that owns all the rest of the stuff. We don't do like a whole lot of stuff here in the Flying Scout mod. On app startup, we essentially add the debug spawnable object type, and we load the sound. This is actually something that I did like maybe 2 or 3 streams ago. The Flying Scout, of course, has this jet engine sound, and to be able to play that jet engine sound, we need to load the timbre project. So the audio engine is called timbre. We need to load the timbre project to be able to play this sound here. And that other thing that we looked at was this, just adding this vehicle Flying Scout to this menu, debug action spawn object menu. So that's basically like these lines here, right? But we don't need to do any of that. The sort of meat and potatoes of the Flying Scout mod is here in this Scout Jetpack component. So this is a component that is actually added to this vehicle, and then it adds this ability to fly, right? It adds the thruster flames, things like that. Left thruster flame, right thruster flame. Yeah, and then we have a bunch of other sort of middleware here, essentially like all of the libraries that like make up the modding SDK, and we're gonna need to use these for the mod. Obviously, I'm hoping it is obvious, but we'll see. Okay, so let's make a copy of the Flying Scout mod and just get to work, shall we? So let's call this first person camera, FP camera, just like that test mod that I had previously. seems like a good idea. We'll take, like inside FP camera, we're gonna have a build folder. I think Sig might actually create that for us, but let's just create it to be sure. We have a code folder. The code folder will have a source folder where the actual source for the mod goes, and then we have the build scripts, right? Flying Scout code workspace. Yeah, we can make a new one here. Let's call this FP camera. Code workspace should look basically the same, I think. And then in the source, let's look at what do we have here. So we have a folder for the components, but I think I'm gonna leave that out. We also don't need a thruster flame, but I think we're gonna need all of these files. So let's move them over, like so. We can close that down because I think this is essentially it. Flying Scout. Let's just call this FP camera, like so. Main and mod controller. And I think this is all that we need. It's gonna be a pretty small mod after all. And what about this guy then? We open it up. We can see that, okay, yeah, we have some hard-coded paths here currently. These are things that I'm probably gonna have to change for you guys if I put these mods as like example mods somewhere when the modding support launches. But for now, these are just like hard-coded paths to where the modding SDK is found, and then also the traction point modding, which is the means lib. Means lib is like the library containing all kinds of things, all kinds of information about traction point itself. And then we also need a mod JSON file. So let's create that actually. Let's copy that guy and create a new file. And we call this first. How do we write this? Is it first person like this? First person camera. Right. This mod adds a first person camera to certain vehicles, right? Like I said, I think this thing is gonna need to know. I'm in a completely wrong place now. I think this mod is gonna need to know about all of the actually, yeah, this goes in. Sorry, I'm kind of thinking out loud here. It's gonna go in the build folder. There we go. Just put it there and let's call it mod.json, like so. Yeah, I think this mod is gonna need to know about all of the vehicles that it can add first-person cameras to, right? Specifically because of the local offset. Like the camera goes into different places depending on which vehicle we're talking about. We'll see. Alright, so we don't need any of that. We can close that as well. And now we can go into code and open our FP camera code workspace. I wonder why some of these are like opened already. Seems completely random. So what do we have? We have FP camera, we have main, and we have mod controller. These build scripts, I don't think we should really have to change. Yeah, you can see here that I already have these paths here set from the previous mod, so I think this is all just fine. We do need to actually change the library name though to I guess FP camera is what I've used everywhere, so let's use that. FP camera is the library name. That's going to be the output of the output, like the name of the output file. So the WASM module that we're going to be compiling, building. And here we can see that, like, by default we're building this as WASM, WebAssembly. So in Traction Point, mods can be built as either DLL, so native code, or as WASM modules. And WASM modules is what you typically want to distribute your mods as, if you can, because that makes the mod cross-platform, but like most importantly, it also makes the mod sandboxed, so that the mod can't, for example, run any malicious code or anything like that. But the WebAssembly support is a little bit in progress, so we're gonna start with WebAssembly, and then at some point, if we realize that there's some features that we haven't ported, I haven't ported over to WebAssembly yet, then we might actually have to switch this to false. We'll see. We'll see if and when that happens. And if we get it working, then maybe we can actually port over that stuff to WebAssembly at the end. But we'll see. Yeah, the rest of this stuff is just like boilerplate. You don't really need to necessarily ever touch these build scripts, other than what goes in between these two lines here. But this should all be set up for me now, because this is sitting like right next to this other mod, so the path to the actual SDK and mean sleeve should be exactly the same. That's good. What do I have here then? And yeah, you can see actually I've started adding this BSD3 clause license agreement here to the beginning of all my mods, because my like example mods, because that's what I'm thinking I will use for these mods. So here we have just some imports, mod controller. Yeah, that one we don't have, so let's just take that away. Flying Scout mod controller. Let's call this first person camera mod controller, right? So we're just shortening it here by like not having that mod controller thing there, shortening it just first person mod controller, and then we actually have a pointer here to a first person mod controller. And if we go here to the mod controller zig, we need to obviously rename this to be first person camera mod controller. Maybe that's a bit long. Maybe we should just do we should just do FP camera mod controller, right? Same as we have here, the FP camera.zig file name. And then when in main, we're gonna come back to this. I think this is probably where we'll hang out for the rest of the stream, really, in this file. But here in the main file, we need to do FP camera, and that's going to be FP camera as well, right? So we import FP camera, and we set this to be FP camera, and that has to be the FP camera dot mod controller. And same thing there. Same thing there, except we don't actually have any components, so we can just leave that as it is, right? I wonder if we actually should do we need to call this somehow? I don't think we do. I don't think we do. We can just set it to an underscore, which is Sig's version of like, I don't care about this. Actually, let's not do it like that. I'm just gonna remove this autofix instead, to like explicitly ignore it. Maybe we'll add some components later on. I don't know exactly. So what do we do here? Okay, we have some export fn, exported functions. This is gonna get called by the game engine when this mod is loaded, or by the game essentially. Yeah, I think it's actually the game that calls this. Init library, and then the init library when the thing goes away. This is called by the game engine to register component types, but we don't have any, so I think this is how we want to actually do this. Just like not call anything here. Let's see, do I have any notes on that? Yeah, I don't, but that should be fine. Should be fine. Right. Oh, Unblue says Z, yes. today is a laid-back Zig session. It's very laid-back. There's barely any viewers today. Maybe this is a bad time of day or something. No matter, that happens sometimes. Oh, we don't actually have fuss, I think, included anywhere. No. Now fuss is a little bit of a weird library that I don't think will be part of the modding SDK even. Let's just get rid of that. Let's see. I think this is all we need to do here. So yeah, when init library is called, we create a new mod controller of this type, FP camera mod controller, and we assign it to the pointer. We just basically hold on to it, right? And when it is time to destroy the library, we call it destroy. Now this is not how you typically create things in Zig, right? You just use the allocator here, and you create something using the allocator. This basis mod controller create function here does a whole bunch of other things, like it registers the mod controller on the C++ side and creates like an interface, so like a virtual function pointer table, so that we can actually like sort of magically, automatically have these things be called depending on what you have actually declared here, right? So that's why this thing is created using this weird basis mod controller create function. You just actually give it the allocator like that. And same thing with this one actually. I don't think, yeah, we don't need any of these. Any of these things because we don't have any component types. That should be fine. Should maybe put on some other music. I think this is maybe a little too laid back. It's a little too laid back for me, this thing today. Yeah, that's probably better. Rightio. I think this should be almost all the boilerplate that we need to do here outside of the mod controller. We could maybe try building this now actually. So let's go into here and open an integrated terminal, then just do Zig build. Let's see what happens. Alright, so it did build. And if we go to FP camera, build, yay, we have a WASM module here. So this is now something that we could already actually use, right? It wouldn't really do anything because we've taken away the components, and this stuff is already done there on the other part. But we could maybe try just loading this thing, just to make sure that we can actually load the mod into the game and see it there in the list. I'm gonna get rid of these things, yeah, all of that, and we'll take mods. So here in the app data, we can basically take the output of this build folder here and put it here. But I'm just gonna do this instead. I'm gonna create FP camera like this, and I'm gonna copy the mod.json file from our build folder, this guy, directly into here. So now we're sitting at app data roaming trampoline mods FP camera. We can actually just build straight into this folder, which means that when we make a build here, it just immediately is in the correct place for the game, right? That's very handy. Yep, this is the thing that I already changed when I changed that name. We have the FP camera name there immediately. So output directory, rather than being build, just builds directly into the FP camera. So that was a path that I copy pasted from the Flying Scout mod. So now if we build this Zig build, we should see the WASM file appearing here instead. There we go. There's a WASM file. So now if we run the game, let's go to, yeah, that's the game. Let's see what happens. So, mods. Alright. Here we have two mods. One is loaded, the other one is not loaded. This mod adds a first-person camera to certain vehicles. It is sandboxed, but it is not enabled and it is not loaded. So enable just means that we click enable here, and now it says, okay, restart to load. You made changes, restart the game to apply them. Hey Zydlo1. Welcome to the stream. Or I should say welcome back. I think I've seen you before. So, right, now it's loaded. So, enable true, loaded true. So now we are actually running two mods. Let's see here. Scanning mod folder for mods. So we loaded one zig component from one mod, no zig components loaded from the other mod. Okay, cool. So that logic kind of works. We don't have any mod components in this FB camera mod. And yeah, we are allowing on sandboxed mods because I'm sort of thinking that we'll need them later on. Okay. Coolio. So now then, now we should be able to just keep writing code there in this one file, mod controller, and build this thing, and it will be essentially like directly hooked into the game. And we just need to run the game and see our changes. So that's pretty cool. So what do we need to do then to actually have a first-person camera? Basically, we have a few things that we need to do. We need a function to activate the first-person camera. We need a function to deactivate the first-person camera, and we need a way to actually like call those things. So let's start by actually creating that. So a function here, activate, and it is actually like a member function of this guy. So let's call it self, and yeah, that's enough for now. Essentially, I'm gonna activate, and we can probably print here. Basis print activate first person camera, something like that, right? Just so that we can see that it actually does run. And then deactivate, well, we're gonna essentially like copy paste this guy and just add a D here. Deactivate first person camera. So that's like a first step. And we want this activate to fire when the player has switched to a new vehicle, and we want this deactivate to fire when the player, well, essentially before the player has switched, when the player is switching to another vehicle, right? So when the game runs or starts, we essentially want this guy to be called once, because they're getting their vehicle. And then when they switch to another vehicle, we want this guy to be called, so we deactivate it, and then we activate it for the new vehicle. Right? That probably makes sense. And so how do we make that happen? Well, we can create something called a message node, and we can listen to messages. So a message node is like something in the system something in the messaging system that can send and receive messages, almost like a mailbox of sorts. Components can send and receive messages on their own because they have sort of like that functionality built in, but the mod controller doesn't have that, so we're gonna need to have actually create a message node here. And the way you do that is quite simply by let's create like some lines here for myself. I kind of like to separate these different sections with these lines. So we have the section here for the members. So this guy needs a message node. Message node. And it's gonna be a pointer, but I think we're gonna have to have it as an optional pointer. So basis messaging message node. And we set it to null. So it's null by default. And this thing is going to run both on the client and the server, but we're going to only be interested in the client here, because the server doesn't really render anything, so it doesn't really deal with any cameras. So it has really like no idea about any of this. It doesn't care, quite simply. And in on app startup, we're actually doing this kind of cryptic thing here, which is again copy-pasted from the Flying Scout code. I'm not gonna go super into detail what happens here, but basically this thing is called once if you are using a native library. So once essentially for the client, and then it's called twice, so for the client and the server if you're using a WASM library. And that is why if we want to run code only on the client, like only on the client, everything that goes into this if is fired only on the client. When if the library type is a dynamic native library, or it's a WASM client library, right? So this is essentially like a kind of a special case here. Normally you just ask like on client, on server, but in the mod controller this is a little bit of a special case. So code that we only want to do on the client we can run here. So let's just get the client from the self context get client. We also have a server here. If we do this get server, this will now be like a null pointer too, because we don't have a server on the client, but we do have a client. So that's neat. And with the client, we can create that message node. So let's do self message node is client, client create message node. And we need to give it a name. And since this is going to be essentially like a singleton almost, this mod controller, there's only going to be one of these guys. We can just give its name like that. That's fine. So this message node now has functions for sending messages with parameters. It can subscribe to message categories, and it can receive messages, right? And it can allocate message parameters. But we're not really going to send any messages here. We're only gonna receive messages, right? So right here we are creating the message node, so we can just do the question mark thingy here to immediately use it. So this basically means that like if you're new to Zig, this is an optional message node, which means that essentially we would have to check for null pointers here. But here, since we are immediately creating it, and I know that this thing here actually complains if it can't create a message node, we know that if we got here, we do have a message node here, so we can just use this question mark here to unwrap that type. And we need to hook this, we need to give it something that is going to get called when this message received event is fired, right? So let's create a function for us. I'm gonna just copy paste that thing. It's typically called on message received. You can see we have a few of them. They all have the same. That's actually not a good. That's not a good one. Let's use like. Oh, actually, I need to find it in the game. Of course, the game has like much more code. So on message received. I'm just kind of cheating here, right? So this is the sort of this is the kind of function that we are looking for. And I'm gonna put it here in the mod controller beneath these two activate and deactivate guys. And this guy doesn't need to be public. Let's get rid of all the code there inside of it. So on message received, again it's a member function, so it takes a self. It takes the actual message, and message is actually just a shortening for basis messaging message. And then we have what is the next thing that we have? We have the message parameters. So let's shorten that as well. Yeah, like that. And if we want to, we can even shorten this message node here, right? We can just do const message node is that. So then we don't need to do any of this. We just do message node. Right, so on message received here, we just initialize it as a method. Receiver type. Let's see, what is the... Oh, come on. This one. Init methods. Receiver type, receiver, and then receiver type, and then the member function is what we have. So we have self, which is the receiver. We have self with a big S, which is the receiver type. And then the function is the on message received. And we want only on message received. Like so. So here we're hooking up when this on message received is fired. We're hooking it up to essentially this method here, right? This will fire when we get a message sent to it. It's a little messy sometimes when VS Code tries to be helpful and give the message, give the functions, you know, the fully qualified like function prototype and whatever with all of the arguments and everything. You have to like go and delete those. But I hope that was clear. So now whenever this guy gets a message, this is gonna be fired. But you don't get just all messages sent to everyone, because that would be very... I'm not sure if it would be slow, but it would definitely be slower than it has to be, because not everyone is interested in all of the messages. So you have to do this thing called subscribing to message categories. So subscribe to message category, and we are specifically interested in whenever the vehicle is set as the avatar and whenever it is unset as the avatar. Now here is a little bit of a problem currently. We have something called engine messages, which essentially hosts these things. ZLS for some reason doesn't show me anything in that. Instead, what ZLS does is it gives me some output here about some failed Zig translate C command, error end of stream. I don't exactly know what this is about, because the code actually works completely fine. It's just that CLS doesn't currently handle this for me. So it doesn't give me any kind of autocompletion. But I do know that these messages are actually found here in this is actually a header. This is the only header, the only non-Zig part of this whole SDK. Is this one header, which is you used to both to drive the C++ side, but it's also fed to Zig, so that we can do the translate C business. And here we can see we have avatar tracking messages. So avatar is set and avatar is cleared. These are the two messages that we want to listen to. So let's just like copy those guys in here, comment them out. And we can also see that they belong to the message category avatar tracking. So that would be the, well, essentially that thing, right? Yeah, subscribe to this category, and then we get these two messages. And you can see here that the categories are up here, Avatar tracking is one of them. It's the second one, and it has these 3 messages. So this header file, this C++ or C header, I should say, is included in the modding SDK. And if you ever want to make mods for traction point, I'm sure at that point it will give you nice auto completion for this. But for some reason now it doesn't do it for me. I need to probably like update my Zig or my ZLS version or something. I don't know exactly. So let's listen to this and call the activate and deactivate function, and that should already give us some sort of something that happens in the game. So we switch on the message, right? And we switch on basis engine messages, and then we have this set active avatar. So that is when a vehicle is given to a player, essentially. And then we have clear avatar, and that is when the vehicle is taken away from a player. We are going to need the else for sure. And let's see here in the game code, if we look for this guy, search for that guy. And here's the actual generated code. But here we can see, okay, so we have 2 parameters for this message that we're gonna want to actually get. Yeah, I don't care about the auto fixes for now. So when the set active avatar message is sent, we get the avatar object name hash and we get the host ID. And I think for this one we only get the host ID, if I remember correctly. Yeah, we only get the host ID for that one. Right? Yeah, this is a little annoying when you don't get the IntelliSense there, but this is really the only part, I think, that we won't be getting it. And so host ID essentially identifies the player. In the single player game it's always 1. The player's host ID is always 1. And the server's host ID is 0. And then if you have more than 1 player, it's like 2, 3, 4 and so on. However, to be sort of good citizens, we want to do this. We want to get the client, again, self context, get client, and then we want to check here before we do anything with this message, because we're not essentially sure that this is that this message is about us. It could like theoretically be some other player in the multiplayer game that has, you know, received a new vehicle. So we want to make sure, okay, host ID. If host ID is our client's host ID, then this is like this means us, right? This message was sent about the player that is currently playing this thing. Yeah, I think we can probably get rid of all of that. Yeah, sender name hash is not really used here. I'm just gonna remove the autofix there, leave that in. That's fine. You get a name hash, which is essentially like the hash of this thing, the name you give when you create the message node. If you want to figure out who sent this message to me, you can ask the system that way. Okay, so let's actually not even call these guys here yet. Let's just do basis print. We got a vehicle, and we lost our vehicle. That is essentially what that means, right? So if we now build this from the terminal, and of course it doesn't build. Error union is ignored, huh? What? Oh yeah, that's not supposed to be an error union. Yeah, that's because I copy pasted that thing from somewhere else. There we go. Now it builds. Let's clear that. So now if we run the game, we should see those outputs there, because we are already running that mod. We have the mod loaded and enabled. Yay, we got a vehicle, right? So now if we switch to another vehicle, let's just spawn a vehicle there, and we drive over to it and we switch to it. Look at that. We lost our vehicle and we got a vehicle, because we are... What happens is that first we lose the current vehicle for, you know, a few nanoseconds, and then we get a new one. So we always get, we lost our vehicle, we got our vehicle. And that's the thing that I talked about previously, about the fact that, like, first we want to activate it, and then every time we switch vehicle, we want to deactivate it, and then we want to reactivate it, right? The first person camera. Or rather, we want to deactivate the first person camera, and then if the mod knows about the type of vehicle that we have switched to, then we want to reactivate it, right? So we got a vehicle. This thing should check. Okay, is the vehicle that we got, is that something that the mod knows about? And if it knows where to place a first person camera, then, you know, we can use that. I hope that makes sense. Oh, we can't block the program like that. Coolio, we're finally getting some viewers. That's nice. Maybe I started a bit too early for people to actually come in, but you're essentially like you're right on time, because I've just done all the boring. I've done all the boring boilerplate here, so that's cool. Feel free to ask if you're wondering about anything that I'm doing here. So now we have the message receiving part done. Now we need to actually figure out, okay, what actually happened, which kind of vehicle did we get, and then we need to actually create a camera and attach it to the vehicle someplace, and then like disable the normal camera, right? And probably store the normal camera somewhere so that we can get it back later. Something like that. So so yeah, let's declare some types for ourselves here. Essentially everything that we do with the renderer, so you know, cameras are one thing, but like meshes and everything else, they live in something called render scene. So let's make a render scene for ourselves here. I'm gonna actually probably shorten some of these types again here to make it a little easier for us. First of all, we have the renderer, which I think is renderer pointer. Let's see, basis, renderer pointer. Yes, we're gonna want the renderer pointer. We're gonna want the render scene pointer. That would be basis render scene pointer, and then we want the camera pointer. Camera PTR. So those are things that we definitely want from the renderer side. Then we need something called a scene node pointer. That would be basis. It's in math actually. Basis math scene node pointer. So things aren't just added to the scene; they're actually attached to a scene node, and the scene nodes make up this sort of like tree, transform hierarchy, transform, you know, scene graph essentially, where you can nest things under other things and so on. And so we're gonna have to actually create a new scene node for the first-person camera to actually attach to, right? Right. What else? Game object pointer is probably something that we're gonna want to And with PTR basis, game object pointer, because we're gonna want to actually deal with game objects for figuring out which object is the player's, all of that, right? So let's see, do I have anything else? I think this is probably a pretty good place to start. So the first thing that we're gonna want to do is let's do one more thing actually here. Let's add a boolean here. Active bool is false. So we track whether or not this thing is actually active, whether or not we have an active first-person camera going or not, right? And if we got a vehicle, I'm just gonna get rid of all of that essentially. If we got a vehicle, then we want to check at this point, like, okay, are we currently active? You know, if active, then do self deactivate. And deactivate would just set active eventually to false, right? It does something else first, but it sets it to false. Activate sets it to true. Does something else first, and then sets it to true. So we have the state kind of like figured out there already. Cool. Let's make sure this builds before we do anything else. I'm gonna save that and then do build. Right, so that builds. Okay. Now then, we want to figure out what kind of object we got. So we do know that this is actually our avatar that was set because we're checking the host ID. We're making sure that the host ID for this message is actually our client's host ID. The object that was set is given here as a name hash. So avatar object is, of course, that's the car in this case. And the name hash is like a string hash of the name, right? So we can actually use that to get a pointer to the object. So let's do, for that we're gonna need the game state. So let's do const game state is self context get client. Or actually we do have the client there, don't we? Yes, we have the client. So don't need to get it separate. We have the client and get game state. Right, client is up there. Yep. Right. From the game state, we can actually get a pointer to the avatar game object. So avatar go, that would be game state, get game object by name hash, right? And then we give it the avatar name hash. Hello, Manish Shergil-W5V. Excellent name. Welcome to the stream. Right, so this, as you can see here, it has a question mark there in the hint, in the type hint. So we need to check it if we actually did get avatar go, and if we did, we can capture it like that. And I think we should probably just store this at this point, right? So let's put a field here for that. So we have avatar game object. That would be a game object pointer. Initialize it to null like that. And we do self avatar go is go. You might be wondering, okay, what is the difference here between null with a small n and a null with a large N and a dot? This null here is actually just like a constant, because these types that end in like a PTR, they're not actual zig pointers. They're C++ pointers that are kind of wrapped in this zig-like interface. So this is not null in the zig sense, it is null in the C++ sense. Essentially they mean the same. Anyway, so here we store the avatar game object. And then we need to figure out somehow, based on that, where to actually put that first-person camera, right? Well, first of all, the first thing we can do here, before we get ahead of ourselves, let's get the type name for the I can just get it from geo here. Get type, which is a string, and we can print that string to make sure that we have new vehicle is, well, is of type, right? I'm gonna do type name here, like that. That should tell us if we have this thing set up correctly. Whoop, no. Oh, look at that. We have the first issue with the with the WebAssembly. Hey Jake, welcome back. Yeah, so okay, this is what happens because, like I said, my WebAssembly interface is very much work in progress. So this is what happens when you call something that is not implemented for WebAssembly. If we go have a look here, you can see that we have these compile error things for, apparently you can't get the name or the type from the game object in WebAssembly yet. Okay, that's interesting. Maybe that's something that we can actually implement later on in the stream. Let's have a look. But in the interest of just getting on with the mod work, I'm gonna make that false, right? And I'm gonna delete the zig cache just to be sure. And we can go into the build folder. Oh, that's not it. Is it here? It's not there actually. It's this one, right? So here's the kind of like the deployed mod, right? The WASM file. Now if we build this, now that I actually set that to false, and it can be overridden here with this as well, but whatever. Set that to false, and if we now build this, we should get a DLL here instead, right? Let's see if that happens. Hey, there we go. So DLL, we'll even get debug symbols for this, so that's nice. You can actually debug your mods in a normal debugger. It's pretty nice. I'm gonna delete the WASM file because the game is gonna try to it prefers WASM version, so I'm just gonna delete that. And now if we run the game, we should see, hopefully, that the mod is still loaded. Yep, it's still loaded, but it is of libtype native. It's unsandboxed now, while this flying scout mod is sandboxed. So running unsandboxed mods is actually probably a bit more performant, but it is unsandboxed, so it's potentially like it could contain any code at all, really. Anyway, let's see here what we have. So if we press F now, we get new vehicle is of type vehicles gripper truck, right? Veloster vehicle, new vehicle is of type gripper truck. And if we switch back, and again I don't block the input, we get new vehicle is of type vehicle scout. Cool. So it does actually find the correct vehicle for us. That's nice. And it gets the name out of that. Very useful. Right, and now I think this is the place where we just need to, like, you know, mod into, or hard code, whatever, into the mod some positions for those first-person cameras, right? In the local space of the vehicle. So let's add a function here to do like get attachment position or something like that, right? And this just gets a game object, which is a game object pointer, and it returns something like an optional vector tree, right? So it can return null if it doesn't know what the object is. Something like that. So I'm gonna take this line here and move it in there. So we get the type name, which again is a string. So we can do if basis string type name, and then we have some type here. Then you know this is gonna be basis math vec3. Maybe we can shorten that as well. It's a little annoying to have to work with that long of a name there. Vec3 is basis math vec3, so we can just do vec3 init 0 0 0. Right, and the type name, of course, is, well, what we just saw. But let's, well, we can do this. We can do this. I don't know what the easiest way of getting these things are. Probably going through the asset browser and copying the names out of there. But we can actually use our mod to get the names. So let's do like, let's put a mother there, and we'll put a gripper truck, and we'll put a flying scout, right? And then we can switch to that, and that would be, that's the name of mother. It's vehicle's mother. And then we just put that there. Boom. And we do, what do we have? Like 4 different vehicles or something like that. So just make a few else ifs here. Super basic stuff. So switch back to that one. Oh, and of course, yeah, we need vehicle scout as well. So vehicle scout is probably like the first one, right? And actually, it is like, if it is the scout or the flying scout. So if we go and drive over to this guy, and switch to that, it's vehicles flying scout. Copy that, because they will have the same position, right? And then we have the gripper truck. I'm stuck. Drive over to this guy. What do we have? Vehicles gripper truck. So we have scout, flying scout, mother, and then gripper truck. And then, okay, so we can do else, and we can do either like vector 3, like 0, for example, just return a 0 vector, or we can return null, because this is an optional here. I don't know which one is to prefer here. The null could be like a pretty easy way to just like not enable a first-person camera for a vehicle if we don't know what that vehicle is. But, I don't know. Let's keep it like this for now. And, yeah, these are all just 0 for now. We're gonna have to come up with something for them. Probably by just testing. But, basically, in here, after we've deactivated, let's see. No, that doesn't go there. That goes here, doesn't it? Yeah, we want to check if it is actually if it concerns us at all. So basically, like, does this concern us? The same thing here in this clearing of the avatar, or is this just some player in a potential multiplayer game got an avatar? Does this concern us? Yes, it does. Okay, are we active? Then we deactivate the current first-person camera. Then we get the avatar game object, and we assign it here, and here we can do if get attachment position for the game object, and if that is not null, then we get a position here. Right? I think that makes sense. If we don't get a position here, then we've deactivated the thing there. We don't do any activation, so we're not gonna activate. Yeah, maybe it makes sense to add this local pos, or let's call it attachment pos, which is vec3, like so, and we just call here self activate, and we give it pos. There we go. And same thing actually here in this clearing of the avatar. If we lost an avatar, then we check, are we active? If we are, then we deactivate, right? That makes sense. So now we've arrived here, and this is probably where we will actually spend the rest of the time. Yeah, I think so. Let's print this position. So attachment pos is, let's see if I can remember how to properly format things like that for 2 decimals, right? So we should get these nice outputs now. On all of the rest should be just good. Let's add some different positions here, like the scouts. What should the scouts have? Maybe like start with 0.5 and 0.5. The mother, I have no idea. Let's do 5 and 5. It's so much larger that I don't exactly know where that thing is gonna go. Gripper truck is probably even trickier. I don't know. I have no idea. Let's do 0.5 and 1.5, something like that. Just that we can see that the data actually flows here into this activate. This is where the magic is gonna happen. Or I'm hoping the magic is going to happen. If I'm forgetting something here. So let's add a gripper truck. Let's add. We can add a mother. Just to make sure that we get some different values. All right. So here we go. 5 5 or 0 5 5. 0 0 5 0 5. Good. And then this is like, yeah, 0.5 and 1 and 1.5. Excellent. Cool. Okay. So far so good. Now then, how do we actually put the camera into the scene and add it to that guy? The first thing that we need to realize here is that there is actually a camera going on, a camera rendering already, and we need to like hold on to that if we want to like put it back later on, right? So let's start by doing like, okay, we have a renderer, which is a render pointer, and it's null. We're gonna have to get it. We're also gonna have to get the render scene pointer. It's also null. And we have the previous camera, right? Previous camera, which is a camera pointer, and it's also null. And let's get these guys and fill them with values. So the renderer we can probably get from here. Self renderer is client.getRenderer, I think, yes. And then self render scene is probably self renderer.get. Is it primary scene? Yeah, I think it's primary scene. You're gonna have multiple scenes. Sometimes it's very useful for rendering things in the background. The primary scene is the one that the game is actually rendered to. Right, and then the next thing we're gonna have to do is here in activate. If we have self renderer get main camera. I wonder if it's that one actually. Yeah, I think that is that is what we want to assign to the previous camera, right? Because we're gonna put the main camera back. So the main camera is like this is the camera that is currently being rendered to. Or rendered from, I guess is perhaps the correct term here. And we're going to want to actually remove that from the render queue. So let's do renderer remove camera from queue self previous camera, like that. Remove, get a pointer to it so it doesn't, you know, we don't lose it, but remove it from the queue. So we no longer render from that camera. And then we're going to want to create a new camera. So let's create a new member here. And we can call that probably FP camera. Like the actual, the name of the mod itself. First person camera. We're also going to need to have first person camera node. Which is one of those scene node pointers, right? Because we can't just add a camera into a scene, we need to create a scene node, and then we need to attach the camera to the scene node. Right. Yep, I think that is perhaps everything we need. Now that I think about it. So, where's the thing? Here is the thing. Okay, so we have to create a new camera now. I think it might perhaps make sense to just create a new, like later on if we want to make this really fancy, we could in theory have like different kinds of cameras depending on what vehicle you have, that sort of thing. So let's just create a camera here. Let's create a camera. At this point we know the game object that we are going to be attaching it to, right? So we create a camera and then we need to initialize that camera. So FP camera, set perspective, field of view. I have no idea actually. Let's go with something pretty standard, like half pi maybe. It's a pretty wide camera, but I think that's probably fine. And then we do self renderer get aspect ratio, which can change. We should react to that, but I'm not gonna do that right now. I think I use 0.1 and 1500 or something like that. That's probably at least decent. Right, so now we have a camera, which should work more or less. And now we need to attach it to the vehicle. So we can do that in a number of different ways. We can create a completely new scene node, and then we can move the scene node around with the vehicle, but that's kind of stupid. We don't need to do that because we already have a scene node on the client that we've attached the mesh of the vehicle to, right? Because the mesh is also attached to scene node. So we can get that scene node by doing, I think it's called render node probably, or render scene node. I'm gonna do self avatar geo. So that's the object that we stored, our current vehicle essentially. And then we do get render, render scene node. So this is the scene node that is already moved around, and it's actually even interpolated. So we get nice smooth movement with this guy. That's not the case with all scene nodes, but this render scene node is interpolated, so we can add things to it, and it will look smooth. But we need to attach it to this position. So let's create a child node of this, right? So we have not free, but first person camera node is, we do render node, create child node. And then the child node, we can set the position, which you can either set position in space, and this allows you to like set the coordinate space. Do you want to, you know, place this in world space or parent space or even in local space? You can't really move a thing in local space, but you can scale things in local space, for example. But yeah, set position in space. This set position just always defaults to parent, which is most likely what you're going to want to have. So we can just use this and do set position attachment position is that one. Right. Okay, so now we've gotten a render node, which is already part of the vehicle. We've created a child node of that one, which moves around with the render node. But then we need to offset it somehow. So we offset it by the attachment position. So if we move, if the attachment position is sort of like offsetting it forward and upward a little bit so that it kind of like sits roughly where the front windshield is, that position should now be, you know, where this camera node is. So the only thing we need to do now then is, with a little bit of luck, this is everything that we need to do. FP camera node, attach camera, self, FP camera. Am I forgetting something? Yes, I am forgetting something. And we need to add this camera to make. We've just placed the camera there. We don't actually render from it. Yes, from it yet. We've removed the previous camera from the queue. So now that we've attached the camera, we need to do renderer, add camera to. I think it's front of queue. Yeah, I think front of queue is what we want. Maybe mistaken. Let's see. Right. I think this is all good. If we switch cameras or switch vehicles now, though, we're gonna essentially leak some resources here. So before we get super excited about this, I'm just gonna quickly try to get through the opposite here. So, so let's do self renderer remove from camera queue. Now we remove the first person camera like that. And then we add back, add to front of queue. We add the previous camera, right? If we have that. And then we can do self.fp camera node, detach camera, self fp camera. So we do the opposite of that thing. And then we can destroy the camera. So we can do self render scene, destroy camera, self fp camera. And then we do set self fp camera to null. And then we do self render scene, destroy scene node, self fp camera node, like this. I think that is, you know, what we need to do here. But let's see. Oh, still can't. I keep hitting Control Shift B because that is how you build things in the main project. But that's not how you build things in this mod project. You just type sig build, and that's it. Cool. Let's see if this works. I'm a little bit unsure about the deinitialization, but we'll see. See what happens. Hey, look at that. Can't really see anything, but we do have a a camera inside of the vehicle, and it is moving around with the vehicle. And we can see that my shadows aren't really very beautiful at this distance. Yeah, it's a little difficult to drive when you don't really see the road there. Here, you like move the camera probably forward and upward a little bit. Okay, let's just try something here. If I put a gripper truck, can I switch vehicles? Hey! Oh, yeah, this position is really bad, as you can see. You can see a little bit of the suspension there, though, if you're into that sort of thing. But yeah, we can see you can't like rotate the camera or anything like that anymore. So that's kind of stupid. But yeah, it does work. It does work. And you can switch back. Cool. Okay. Let's tweak that a little bit, right? So here's the scout. The scout needs to be moved forward and upward. So let's move it forward like 0.8 and upward like 0.7. Let's try that. See how that works. For the gripper truck, we're gonna have to move it upward quite a bit. What should we do? Like 1.5 maybe? Let's just go with that. Let's see what that takes us. Okay, so now we're yeah, now we're poking through the roof a little bit, but now we can already see what you're doing much better. That's nice. Even get a little bit of the hood there visible. Okay, let's move it just a little bit forward and a little bit downward, right? Let's do like 0.67, 66, 85, something like that. That should probably be good. I'm not sure this game plays very well in first person, but that's like a completely different discussion to have, right? Now if someone wants to do it, then they can. Maybe the FOV is a bit wide. Should we maybe tone it down a little bit? I think we should tone it down a little bit. It's a little crazy maybe to have it that wide. Oh, I'm in the wrong project, of course. Let's see. Here. Let's do like 45. It's pretty cool though, if I may say so myself. Like, we haven't touched the game code at all, right? Oh, I was thinking about the other way actually. I was thinking about it the other way. I kind of wanted to see the inside of the vehicle a bit more. Okay, yeah, so I'm a little bit bothered by that thing. Let's see what happens if we make it 0.55. I just have to completely reverse my decisions here. But it would be cool if you had a replay after you finish the level and you could watch it in first person. Oh, yeah. This is think the cockpit looks a little nice. I mean, it doesn't look nice at all, of course. It looks kind of ass. But I think like the view is maybe a little crazy. It's a little fisheye. It's a little fisheye like this. Anyway, what I was about to say is that I'm kind of proud of the fact that like we haven't touched the game code at all. The game is completely vanilla, right? The game code is completely vanilla. We haven't modified it at all, and we are able to do these kinds of things. I think that's pretty cool. And I should add, we can combine this with the other mod, right? This one. Hehe. Hey, take off. Oh no. I need more collision sounds and effects. This is kind of majestic. Yeah, I can't look around or anything like that. That would be fun. I think that you kind of want to see a bit more. You kind of want to move the camera up a little bit, but I'm thinking I'm a little afraid that we're gonna poke through the roof again if we do that. But yeah, this is this is interesting. This is interesting. Okay, let's undo a few of these things here a little bit, I think. Let's do 45. And let's move it up just a little. Back up to 0.7 and then move this forward to 0.9. We can even go a bit further than that. 73. We get like a little bit more like almost like, you know, hood cam with this. Yeah, this is proper hood cam. Get rid of that mouse cursor there. We can add some or run some scripts here to open the main gate like that. It's fun. Cracked windshield when you crash. Yeah, that would definitely fit this game, but yeah, I don't currently see the insides of the windshields at all. They're single-sided materials, so you don't see them from the inside at all. This is kind of interesting, right? Not sure this plays very well in this camera mode, but hey, it's all good, all in good fun. Right, let's see if this thing got any better. Ah, all right. Now we're inside of the cockpit. There, you can see there's even some like chairs and things in this one. We're definitely not in the correct place. Oh no. See if I can find those other guys. Let's switch to them. I can hear the sound. There we go. Hey. Yeah, this is a flying scout. So we can take off. Hey. So here we have two mods working together, right? Suddenly this is some sort of weird flight simulator. I'll try to land smoothly. Oh no, it's not gonna be a smooth landing. Well, it wasn't that bad. It wasn't that bad. What about the mother vehicle? Yeah, you get kind of seasick pretty easily. Right, so now if we actually, before we try that, let's put down a test vehicle here. Now if my logic works, when you switch to this guy, we should go back to the normal camera. Look at that. Now we're back to the normal camera, because the function that we wrote there, it returns null. It doesn't know about this vehicle, so we get back the normal camera with all the normal controls and everything. So that's pretty handy. What if we put down a mother and we see probably gonna be somewhere inside? Oh, yeah, we just see the back of this cabin here. So it's super difficult to drive. Actually, we just need to move forward a little bit, and I bet we probably are gonna end up in a pretty good spot. So let's move forward by a couple more units. I'm gonna have to move forward with this one as well, but I'll also move upward quite a bit. Let's try that. See where that takes us. But yeah, we could even have different like FOVs and things like that for different vehicles. That would also be quite easy to do here now. So let's try gripper truck first. Well, it is better. It's not good, but it is better. You can see that the gripper truck is a little bit more of a modeled interior here. Let's move it a bit forward some more. Let's do 0.2 maybe, upward 0.1. I think that's probably fine. That's probably fine. I need to go get some water soon. Yapping so much here. Let's try this out though first. Okay, even still a bit more forward, I think. It's gonna be good. Let's try this though. Alright, here we are already. We're seeing the inside, but we need, like this thing is so ridiculously huge that we need to move forward at least 2 units. Maybe we'll just make it 3 units for good measure. So let's just move it 10 units forward, and this is like 3.6. I keep underestimating the distances I need to move there to actually get into place. Alright, so where are we now then? Mother, gripper. Yeah, okay, this is kind of looking, and it's still a little bit like some sort of AT-AT from Star Wars, but yeah, this is actually kind of interesting to drive like this. I think like if I was to actually like put some effort into this mod, I should make it so that you can look around with the right thumbstick, like inside the cockpit, and then if you let go, it would like slowly move back to like looking forward. That would be kind of interesting. Still, like we're still not where the windshield is. Jesus, so large. What do you want? 13. Is that enough? 6. I don't think it really makes sense to drive this vehicle in first person at all, but we can at least try to make it possible. Alright, well this is better, but it's not good. Let's move it 2 units forward still, and then that'll be enough. 15 units. Oof. Yeah, so the mother vehicle has this weird sort of like almost like dashboard thingy hanging from the ceiling in the front, so it is possible that we're gonna be somehow inside of that thing. good, but let's see. Alright, we're inside of the roof a little bit. You can see we're poking through the roof. Let's move it down. Just a little. Just a little. Hey, Xluxy, welcome back. Let's see. This 5.5 is probably fine. And then build that. Alright. I'm hoping this is gonna be good now. Yeah, this is pretty good. This is pretty good. You can see a little bit of the vehicle there. And even a little bit of the roof, ceiling, whatever. This is weird. It's weird to drive in first person, but it's also kind of fun. And then of course, like there should probably be a little bit of a okay, you get stuck on something and you have no idea what it is because like you don't really see anything in this view. Let's see if we can get past that tree there. There we go. There should be a little bit of springiness to this scene node as well. Now this is very rigidly. It's almost like a camera that is being bolted to the dashboard of this vehicle. Which of course it is. It is exactly that, but like it doesn't necessarily feel very good. And this looks like it would hit that, but I know for a fact that you can quite easily fit under there, so. Yeah. Not bad. I want to see my shadow. I can't see my shadow. Maybe I can see my shadow if I drive down here and then I see it there on the slope. Nope, no shadows today. And now I'm stuck. Maybe have a key for toggling mode. Would help you seeing where you're stuck. Yes. I mean, I'm gonna. If it wasn't obvious already, this is like a complete throwaway thing. This first-person mode. That's why I'm making it as a mod. This is not something that is gonna be shipping in the game. Like this game plays just terribly with first-person driving. So yeah, this is not gonna ship in the game. Just so we're clear. I want to see my shadow somewhere. Why can't I see my shadow anywhere? I did manage to catch my shadow when I messed around with the scout. Ah! Yeah. Again, I'm stuck on something. Yeah, so this is not gonna ship in the game. This is absolutely just for funsies and for actual. There's a little bit of, yeah, there we can see a little bit of shadow. Okay, good. There's a point in actually making this. I am right now. I'm putting just a whole lot of work into the modding system, and so making these kinds of test mods or example mods, however you whatever you want to call them. It's just one way to see how well things work. And you always find things that don't work. Like we already saw that this currently doesn't compile in WebAssembly mode, and we might actually want to fix that today. See how much energy I have. But yeah, this is not gonna go into the game. Don't worry about it. I think I'm probably just gonna open source this mod, and then you guys can can put it back if you want to. Oh yeah, some sort of key would be definitely, that would definitely be preferable. Maybe we can even do that. Like, why not? Why not? Right, I'm gonna go get a glass of water. I'll be right back. Rear view mirror, yeah. Yeah, that could be done. That could be done for sure. Essentially what you need to do is you need another camera that you attach facing backwards, and then you need to render that into a texture, and then you create a material that that references that texture, and then you put that material on you know, something inside of the car. That would give you a rear view mirror. So it's not actually super tricky. One thing I want to test here. Let's see. Can I just actually open? We go to, not that, but here. We go to mods, we go to FP camera, we go to code, and we go to source, and we go to mod controller. If I put a breakpoint here, this is gonna actually fire. Ha! Haha, look at this. Look at this. So freaking easy. When you are building your mod as a DLL, you just debug it. It's wonderful. You can see here, okay. Starting the trampoline exe, we go to basis DLL, and then we go into FP camera DLL. That's cool. All the way from, where is it? Here we go. Game state set avatar object. Right, this is a network message that comes through. Set avatar object. And it calls game state set avatar object. And then we send the message. Here's sending a message on the C++ side. Message set avatar, set active avatar, and then we, you know, we arrive here. Message set active avatar. Super nice. Okay, excellent. So deactivate. I have a feeling that deactivation might be happening too late. Oh, it doesn't happen at all. Oh. Right. Yeah, because deactivation doesn't... Oh. Yeah. Yeah, that's a little bit of an issue. Or, I mean, it could be. Currently, we're only deactivating when we're switching vehicles. We actually need to deactivate when the game ends as well. Otherwise, if you just go back and forth between games without shutting down the game, but you load into like different levels or whatever, you're gonna be leaking resources. So that's not good. So we can listen to another message, which is here. Game ended. Yeah, we actually probably need to listen to game ended and also bailout to shut down. Game ended is fired when the game ends, as one might expect. That is like the game session ends. So if you go back to the game, So back to the menu. This fires. This actually doesn't fire if you just shut down the game directly from the window, because technically the game session doesn't end. You just shut down the program. So that in that case you get this bailout to shut down instead. Both of them do the same thing though in this case. So yeah, let's add that. Let's do message category game flow. I'm gonna go back to our trusty file here and do self message node, subscribe to message category, engine messages, and then subscribe to game flow as well. And then we do endgame and bailout to shutdown. Like we want those two. So let's get rid of, oh, not endgame, no, sorry, not those, but those two. And yeah, again, this is a little sad currently because this just for some reason doesn't work with ZLS. So I need to update my ZLS. It's a little broken. Self deactivate. Right? Actually, you know, we want this entire thing. If active, then self deactivate. Yeah, that should be good. Oh, I'm running from Visual Studio. Well, that's fine. It's probably just runs the same thing. Oh. Oh. Huh. Ah. Yeah, the camera is probably actually. Either the camera is destroyed or the camera node is destroyed. Okay, we can fix that. Let's do this. Let's do if self fp cam. Let's see, camera is attached. I think that's probably enough. Let's make sure that we can actually shut this down cleanly. What? Oh, here. Okay, this is clearly like a camera issue, right? Okay, so yeah, what I need here is probably like let's do game ended, boolean, and game ended if game hasn't ended, then we add the camera back. But if the game actually has, what should we call that? Maybe game ended is not the correct term here, actually. Well, yeah, let's call it game ended. So if the game actually ends, we don't want to add this back, because actually it might not even exist anymore. So here would be true, and here it would be false. Here it would also be false. I bet that fixes the issue. Let's see. Let's see if it does. Right, so now if we shut this down. Hey. Now we have it working. Okay, excellent. Right. There's something else here that I should. Those comments are maybe a bit stupid. Let's just take them away. Bye bye. I'm gonna leave that comment there if we need these for figuring things out later on. what's an avatar in your use case? Okay, an avatar is just a game object that represents a player. In a game, right? So, you know, you can create a test vehicle and a truck. Oh, I thought I said truck number 2. There's truck number 2. We can put a scout. We can put a gripper truck, and these are all just, you know, vehicles in the game. But then you tell the engine, actually, this is like an engine level thing, even though the engine doesn't really do a whole lot with it. But it just still, you tell the engine that, like, oh, actually this truck here that is rolling away here, this is the avatar. And the avatar is set on a game object, and it is set for a player. And that basically means that, okay, this player is now represented by this avatar, right? And so a player can have no avatar, or they can have one avatar. And if you set an avatar to be some player's avatar, and it's already some other player's avatar, then that player like loses the avatar. And that is how we switch between vehicles here. You switch the avatar, and then you have the game code actually like hook into all of the engines like avatar functionality. So the engine doesn't do a whole lot with the information about what an avatar is, but it lets the game know a whole bunch of things. For example, it lets the game know on the client every frame when the avatar's transform changes. And that is, for example, how we can move the camera around like this without having to like ask, hey, where is my vehicle all the time. If the player has an avatar and that avatar moves, then the engine lets the game code know that this avatar moved. This sort of thing. And the inputs are also routed for avatars like separately. So for example, if you have, let's go to the game objects here, and we can do like gripper truck arm, for example. This is just a component that is added to this vehicle. Actually, this is probably kind of fun. Yeah, now you can see the thing there moving. I didn't even think of that. But yeah, you can see this thing moving here, and that is because the inputs are routed correctly to this object, because I am now moving the triggers on the gamepad to move this thing up and down, right? And I don't have to ask the game engine, hey, which object is my current vehicle, and then have a bunch of if-elses in the vehicle code. The gripper truck arm component can actually just use input reading functions. Probably have some of them here. Let's do like get input range, or get input state, and then also get input action. So this is how the gameplay code reads input, and it just goes like, hey, if the input action reset pose returns true, then you know we start the resetter, which is like if I hold down this, you can see the thing just like resets, goes back to its original position. And the object can just ask, hey, is someone applying input to close the thing, and then it closes the thing, and that system relies on the avatar system to figure out, you know, is this object on the client of the player whose vehicle this is, or is the object on the server, but the client has actually sent input over the network to, you know, for this particular vehicle, and like it handles all of that for you. So you can just, in a networked way, you can just have the object figure out, hey, someone is pressing the action that I need to close the fingers now, blah blah. And so the avatar stuff is used for that as well. Yeah, that was maybe more information than you wanted. I'm sorry. But basically, it's like I think Unreal calls it possessing objects, right? That thing actually like running already, or still? Come on, don't do that. Nah, it's fine. I was thinking that there was some like input that got left on for some reason on that, but it's fine. Yeah, I think Unreal calls it possession. So you possess like a pawn or whatever it's called, actor. I think it's pawn actually. And that's basically like the same thing. You have an input controller or player controller, whatever it's called, that possesses some object. That basically means that like you can control that object. It's the exact same concept here, except here we call it the avatar, and it's sort of like the representation of the player in a game. Okay, that's fun. Now then, should we actually try to make this thing run through WebAssembly? What do you say? That would be. This was like the fun part of this work. Now we could even do a little bit of work. We could do the work part of this work. And that would benefit the project. So I know there was at least one function there that wasn't implemented for WebAssembly. We could maybe make that happen. So let's look into that a little bit. I prefer in-depth explanations. Okay, you're in the right place. You're in the right place then. Righty. So if we go here and we flip the switch on this guy again, back to WebAssembly, and then we remove. Yeah, not that, but this. We remove the DLL and PDB. So we wanna when we build this, we wanna get a WebAssembly module here, and then make sure it actually works. If I can get that going, then I'll be a happy boy. So if we build this now, it will once again complain that the get type thing is not implemented for WebAssembly. What? Render add camera to front of queue. Oh. Right, so we have actually quite a few. We have four things here missing. We have game object get type. And this is essentially the same thing. It's just that like I haven't even remembered to add like a compile error. Then we have set perspective and get parent scene node for the camera. Okay. This is curious. What is going on here? Add camera to back of queue, add camera to front of queue. Why is this? Why is this not working? Have I just actually typoed the thing? Oh, WASM, is it? Yeah, it's WASM. That was an easy fix. Except I don't want to fix it here. I want to fix it in the correct place. So what I've started doing is go see api.zig 4074 API 4074. It's right here. WASM. There we go. Yeah, that was a stupid mistake, but okay, good. Yeah, I have a system now which actually takes the code as I'm developing this game, packages it up, removes some stuff that shouldn't be included, and then slaps some release or some like license text and things like that on it. It's called the releaseinator. Let's see, basis zig. What? What? That's not a file. What the hell? It's confusing. Okay, let's see. Let's shut probably like this down. Ah, that's fine. Let's go here again. Okay, so now we got. Oh, what? GIMP? No GIMP. No, managed to start GIMP somehow. Right, but now we got 0 errors, 0 warnings. That's good. Yeah. Okay, sorry, GIMP. I think that the ZLS somehow held on to that folder, so we couldn't write to it or something. Right, and then we go here again, and now we should be down to 3 errors then. Yes, 3 errors. Set perspective, get parent scene node. It's like a very basic perspective. I think this set perspective, pun not intended. This is a bit trickier. Nah, it's not actually very tricky. It's gonna be easy. This is super easy. This thing is super easy. We can see that we don't actually have any camera functionality exposed to WASM. This is the place in the code base where it splits. So this is a compile time. If this is WASM is a compile time constant, so it either gives us a compile error or it gives us the native version. So you can see that nothing is actually implemented for the camera, but it should be pretty tricky to, or trivial. Sorry, it should be pretty trivial to implement at least those two. This one is a bit more interesting. You can see that for game object we actually have almost everything implemented here. For WASM, just have these two: the get name and get type. And yeah, those guys are kind of annoying, because we're gonna want to return a string from C++ into Zig. So basically from outside the WebAssembly module into the WebAssembly module. And if you know anything about WebAssembly, you know that like WebAssembly modules can't actually read memory outside of their sandbox. That's one of the fundamental ideas of WebAssembly. That they should not be able to read. If you try to do that, then the WebAssembly runtime will just like barf at you and go burp. No. And so what we can do here in C++, or in native code rather, is that when we get the type, which is supposed to return a string, we actually give it a pointer and go like, hey, write write the string to this address, or like rather return the address where I can read the string and store it here in this str interrupt string pointer. That's a C pointer in Zig. And then the native side can go, oh, okay, here is the address to the string, and then the Zig side can look at it from here. But that won't work with WebAssembly, because the WebAssembly code, in other words the Zig code, is not allowed to actually read what is going to be stored in this guy. Unless we jump through some hoops on C++ side, which I think we might have to do. Might just have to do that. Okay. Let's do the camera first, maybe, because that should be in some ways easier, in some ways trickier, because we haven't done anything with the camera. So I'm gonna have to just put a place there in the C++ code where we actually can even do that. But that should be fine. So this stream turned into a WebAssembly mod support stream from a first person mod stream. But hopefully we'll get back to the first person stuff in a little bit. Let's figure out where to actually even start with this. Where is the thing that is right above the camera or below? If that is the easier part. Okay, that's not the correct one, it's this one. Mesh instance. And then below the camera is displacement effect, which also is not done in any way. Okay, I'm thinking that the camera is probably in renderer bindings, basic renderer bindings. This is probably the camera. Yeah, here we go. Here is the camera stuff. Actually, here's the camera stuff. So we needed set perspective, so the first one and then the last one. Those are the two ones that we actually use here. Okay, that's fine. And above it we have material. We don't have actually any of these guys. We have render scene. Oh, we actually have material, right? Material is there. So we basically need a section here for the camera. Yeah, this thing. Okay. So let's just get that guy and copy it here. I'm gonna do only the ones that we need right now, to not like drag out this part of the stream like too much. Set perspective and get parent scene node. Now, the way we do the wrapping in WASM with the WebAssembly runtime that I'm using is we add an underscore WASM. It takes this magical execution environment parameter, which I've never used for anything, I might add, but the convention is to have it there. So that's what we're gonna do. I'm gonna forward all the rest of the parameters to this guy, far clip, and that's that. And then we have the same thing here. CPP pointer, and this one actually returns. There we go. And then I'm gonna copy paste. Let's take that one. This is how we register these WASM functions to be callable. Yeah, it doesn't like that I put it there, but it will just have to deal with it. So this one doesn't return anything. Yeah, this is a little strange. This binding interface is not something that I've come up comes from Whammer, or the WebAssembly Micro Runtime. But we take this guy, we expose it under some name. This is the thing that we're gonna have to then match in Zig, this string here, and we bind it to this function. And then we give the we give the what do you call it, the prototype here, basically like the return value, which is a void here, so we don't have a return value, but then you also give the arguments, except this one. Don't put that in there. And the arguments are like 64-bit integers are large I. Anything smaller than 64-bit integers is a small I, and then we have floats is an F. So this would be one 64-bit integer, which is that one. And then we have 1, 2, 3, 4. So that would be I, F, 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 F. And then return values come after the parentheses. If that is confusing, yeah, it is. It is pretty confusing. Here we have just one large I, and we return another large I. That's the one large I, and this is the returned other large I. Of course, you guys don't have to care about any of this. This is my job to wrap these for you, so that you can use them. Right, that should be that. Now these things are essentially exposed to WebAssembly from the C++ side. And they do exactly the same as the native ones. We are still going to have to, like I said, we're going to have to match these names up on the Zig side. And the way we do that is we search for that one. And we can find it here. Not that one, but here. And here we already have. These are actually auto-generated, these things. We have the one for set perspective, WASM. 1, 2, 3, 4. Yes, that looks good. We don't have it for the other one though, because this get parent scene node thingy was added recently, so it's not actually found here, but we can fix it. So it's going to be something like pub extern env fn camera get parent scene node. We have cpp pointer, which is of type basis dot cpp pointer, and it returns another cpp pointer. There we go. Right. So this is like the binding on the Zig side, specifically for the WASM stuff. So you can see there's quite a lot of stuff still commented out here. Not all of it will necessarily ever be exposed to WASM. I'm not exposing 100% of the APIs to WASM, but still I'm gonna have to do most of this. So I'm kind of doing it in the order that I use it, because that way it gets tested as well. Right, so now we have these two, and the only thing that we now need to do is actually hook them up here. So if we go to camera, we can call, rather than doing that, we can do access.camera set perspective WASM, and then we do cpp pointer, we do fov y aspect ratio, near clip and far clip. I might have forgotten the thing, yeah. I was actually just thinking the same. What I typically do here when I do this is let's see if I added that thing here. You know, if you click it here, it jumps to that. I was actually just about to say that. But now if we do the same, oh, that doesn't go there, of course. It's the other way around. If we now go down here to the other one, and you do return basis, actually it's not basis, it's access, and then we do camera set no, get parent C node. Oh yeah, this way it actually would have been missed. So what would have happened here is that the runtime would have yelled at us that there is no such extern in the library with this name. So yeah, it would have been very would have been a very embarrassing thing for me. So thank you for pointing it out. But yeah, normally what I do is that, like, if I write this, or rather like the other way around, so I have this missing from here for some reason. After I've done this, I click it, and if I go like, oh okay, I can't actually control click it, doesn't go anywhere, then I realize that okay, it's actually, it's incorrectly entered here. So if we have the WASM here and you control click this, you can actually jump to it. But yeah, if you like autocomplete it, then it actually, you kind of miss it. So yeah. But yeah, the runtime would have yelled at us immediately when we started the game, because it when the game starts, when you are loading a WASM library, it runs this stuff, and it happens just once at startup. And so it would have yelled at us that, like, we don't have this, thing. Same thing with the native side as well. Okay, cool. This now, if we do the release nation again, which, updates the mod SDKs for us. Now if we run this, or we build this rather, we should have only one. Error. Zip code is where I want to go. Open an integrated terminal, sig build, and yes, we have only one left. So it's the get type not implemented for WASM. And like I said, that's a little bit of a mess to do, but I'm sure we can do it. So basically what we want to do here is we want to go to, I think it's game object bindings. Yes, it is game object bindings. So here is how it works on the native side. The name hash is implemented because name hash is easy. It's fixed length. The name is not. On the native side, this is how we bind the native side. This is how we bind the WebAssembly side. The native side, we give it a writable pointer to an interrupt string. An interrupt string is essentially the same as a slice in SIG, in that it has a pointer and has a length. And then what we do is we get the actual name out of it as just a normal C++ string type, and then we write that. Name is there, length is there. Now the problem here is that, like I said, we can't do this. We can't just give a pointer to WebAssembly and go like, hey, read from this pointer, because the WebAssembly runtime doesn't allow that. So what you can do is you can allocate memory that the WebAssembly module can read from a special allocator, which I'm trying to remember where I've actually used that. Like sig interrupt Just here maybe. Yeah, maybe not. This was like half a year ago, maybe even more than half a year ago that I did this. What was the actual? What was the actual name here? WASM runtime common. Is that the header that we include in all of these places? Not necessarily, but maybe. Oh, it's actually probably the other one. It's that WASM export. And then it's called something like allocate. Runtime module malloc. So that may be it. That might be it. Search for that. This guy. Allocate memory from the heap of the WASM module instance. I think this is what we've done in a few places. Well, apparently not very many actually. But yeah, this is how we can do it. At least normally. You have a string. Here we are, for example, we are passing a buffer of JSON data to the WebAssembly. We get the string here from this, and you initialize it like this. You get the module, then you give it how many bytes you need. Out of that, you get a JSON buffer. You get a buffer. The buffer is essentially like initialized with a handle like this. You also get a native address. The native address is where we'll actually then memcopy your actual bytes. And then that handle is what you can actually pass to the WebAssembly module, and it will essentially see what you memcopied here, like this, right? And then when you're done with it, you need to free it. Now this is the issue here, that it works well in this case because this is called. We know that as long as this function is alive, this memory here is alive, which means that we can copy it here into this buffer that we've allocated, and that buffer stays alive and can be referenced by this guy until this is called. And then the function is called on the WebAssembly side, and then it ends, and after that we can free it, right? But we can't really do the same thing here with the getType. GetType method here, right? Because the getType just like returns a string. We don't really know what the WebAssembly is going to do with it. It might store it in a member somewhere, at which point you're fucked, right? Because when we free that buffer, bad things are going to happen. So we're gonna have to come up with something else. I think this is why I haven't done these things yet. I haven't implemented these things yet. It's a bit of a chicken and egg problem, or maybe not a chicken and egg problem. It's more like a. It's more like a what is the chicken going to do with the egg problem? I bet you've never heard of those. This is one of those problems. Right, because this is the function that we actually call on the Zig side. And we are essentially, we're quite comfortable with doing it this way, where we're actually returning a slice. So we're essentially like, if you haven't done a whole lot of Zig, what this means is that we're returning a pointer to the string data, which is allocated somewhere on the C++ side, and it also contains the length. That's the slice syntax right there. And we're quite comfortable doing that because we know that it's actually gonna point to this memory here. Actually that there, type game object get type, and this thing is a member. It's right there, so it's not gonna die. At least like it's gonna stay alive as long as can be reasonably expected of it. That is not the case here. If we allocate like a temporary buffer, then it's a temporary buffer. So how should we do this? It's a little tricky. Another way that we can do this, if we want to, is to allocate memory on the zig side, just normally with the allocator. Well, it's not really normal. It's the WASM allocator, but still, we just use the normal APIs to allocate memory here in Zig, which of course, if it is compiled to WebAssembly, then it is going to be memory that is owned by the WebAssembly module. And we can just happily give that to the C++ side and tell it, hey, here's memory that we are free to use. Please write the string here so that we can read it back. Yeah, that thing we can do. So I wonder if that is what we should do. Not sure. And what that would then probably mean is that we would do in here. This is where the magic would happen. This str here would actually not point to something on the C++ side like it does in the native version. It would actually kind of be put aside in a special buffer somewhere. This is annoying. Before we do anything more on this, let's see if we have any other issues that we need to fix. So what I can do here is quite simply, I can go into the mod controller, which is here, and I can not do that, but I can just hard code this to be vehicles scout, and then we're just gonna test it out by using only scouts, right? And that should work just fine. It's here, isn't it? Yep. All right. So now we are here in app data, roaming, trampoline mods, FP camera, and here's a WASM mod 2112. That is right now. Excellent. So let's run the game and see what we get. So obviously this is not gonna, if we now try to switch to like a gripper truck, then the camera is gonna be in the wrong place because we're hard coding the scout type name there. But it should at least show us that it works, and it does actually work. That's cool. Let's put a scout down. Let's put a gripper truck down. The gripper truck is gonna be completely wrong now. Yep, here we are again inside of the thing, and you can marvel at the suspension doing its business if you want to. And then we switch to that one and it works, and of course it should also work with Flying Scout, and we can verify here that the mod is actually running in WebAssembly mode. So that part is fine. The WebAssembly-ness of it all is fine. So that's at least nice to see. But yeah, I need to have basically like a. I need to come up with a scheme for handling those kinds of strings that are sort of like not necessarily temp strings, but like almost temp strings. I don't exactly know how to handle those in a nice way. lift up the arm a little bit. We can see a bit more here. Yeah, you don't really see the suspension like this normally when you play the game. You have to go put the camera inside of the vehicle to actually see it. It's pretty fun. But yeah, obviously I need to fix those string issues somehow to make the WebAssembly backend really useful. So it's pretty good that they are exposed like this. That's pretty nice. But I might have to think a little bit about how I want to actually fix those. Since it's not immediately clear to me. But hey, we have a first-person mod. That's pretty cool, I guess. It's also not super. It doesn't play super well, but that was kind of never the thing that I wanted to prove. Anyway, I wanted to prove that I can do this. You can essentially like yank the camera away and put another camera there instead, and then move that other camera however you want. And this can be made much sort of fancier by maybe introducing a little bit of head bob or like springiness to the camera here. See if we can fly to those mountains over there. Making it possible to you know, look around the cockpit, something like that. Axorosmt7042 says, "Nice. I personally like Lua for scripting. Good to see something else." Yeah, this is not really. I don't really consider this scripting. Like Zig is the language that I use to actually build the game, right? I do have a scripting language here as well, called AngelScript, that I use for sort of, you know, one-off things. Oh, I hit a kill. I hit a kill box there. Now it's very slow to fly back there. Oh no. Speed it up a little bit. Whoop. Yeah, I have AngelScript here to do scripting. You know, there's a debug script here, for example, to open the main gate. You can just click whoop, and now the gate opens. That sort of thing. Oh no, not a gripper. That's a horrible thing. Here's Mother again. Here's some more. Here's some more. Some more suspension porn for you. Because again, now the system thinks that we're driving a Scout, but of course we're not. We're driving a Mother vehicle. So the camera is in the wrong place. +1 for AngelScript. Yeah, to be honest, AngelScript is probably not necessarily the most. I don't know how to say this. Like the most easy to use language in this particular project, specifically because I'm using Zig, and AngelScript is designed very much to interact with C++. And So actually making it work with SIG is a little tricky. I've managed to do it, but it's maybe not as ergonomic as using it with C++. But AngelScript has been a part of my game engine for a very, very long time, so it was kind of natural in that sense to make it work. I'm just sitting here thinking about how to fix that WebAssembly issue. There's some easy way I could do that. So it's a sort of a classical problem in a way. Specifically with strings, like I've encountered this issue in completely different code bases. Some code bases tackle this issue by having like a pre-allocated pool of strings. So you get like a temporary string, and then the pool is sort of like cycled so that you can have, I don't know, 10 temporary strings or 20 or 32 or 64 or however many you want to pre-allocate. Maybe they're like 1,000 bytes long or something like that. And then it just like cycles through those. Every time you use a temp string, it like uses one from that buffer, and then you kind of, you better not hold on to those strings for too long, because before long your temporary string is going to be overwritten with something else. And actually I have exactly that system in Basis as well on the C++ side. It used for all kinds of things like formatting, things like that. And then you have that list in like a thread local variable, so that you don't need to lock if you're writing to it from different threads. And that works fine for most things. Like if you want to hold on to something, you're gonna want to actually put it in like an actual string variable, like an object anyway. So it's probably actually good enough for this case too. I don't really have that kind of system set up in Zig. I don't need to necessarily want to do it specifically for this case. So I don't know exactly how I want to handle that. Another way that we could do it is the API would look a little different in WASM. That's kind of annoying. That's not really something that I want to do, but that is a possibility. If you want the type name, and the Zig code is responsible for actually allocating a buffer big enough to hold it, and then it asks C++ side, hey, just write the string here. I have allocated 32 bytes or 128 bytes or whatever. Write the string here for me, and then it is up to me to hold on to that as long as I need it. That sort of thing. That can be done. And that's fine. But yeah, I don't know. That then introduces differences to the native and the WASM SDK, or the API rather, which I actually already I have like a few small differences between the two already, things that I can't really get around no matter how much I try. But this feels like something that I don't really want to do that. That's annoying. Yeah, this feels like a proper rally way, this rally road, dirt road. maybe this camera kind of feels a little bit like a proper rally sort of in-cockpit camera that they sometimes have when they drive those races. Drive behind this building here. Drive back. Proper rally, special stage or whatever it's called. Alright guys, I think I'm pretty much done for today. This was I consider this a success, even though I couldn't quite figure out how to do that. Well, I could hack it, but I don't really want to hack it. I want to think about a little bit how I want to fix that. That's gonna be the next thing for me anyway, probably to expose a bit more of those WASM thingies over the weekend. Next week I'm planning to do quite a bit of work on Steam Workshop support. After next week I'm gonna be away for well, I'm not gonna be physically away, but I'm gonna be away from Madrigal work. I'm gonna do some other work, some work for my other employer for a couple of weeks. It's probably going to be a little bit more sort of sporadic, the work that I do on Traction Point. And then I'll be back in the first half of December to finish up any last remaining things that I have time to do for Pre-Alpha 3. Pre-Alpha 3 is going to release before Christmas, in whatever shape it is at that point. And that is going to be the last Pre-Alpha that doesn't have like a whole bunch of new content. I'm a little sort of annoyed at the fact that none of the Pre-Alphas this year have been like, you know, huge on new content. We have this level, which is it's actually kind of nice, but it's not going to be playable in the pre-alphas in its final form, because this is part of the campaign. So I mean, you can still play this thing, of course, but it doesn't have a mission in it in its current shape. And we have the gripper truck, but those are kind of like the only really sort of big things that have happened. Content. Then we have like just a whole bunch of other sort of smaller things, and of course we have the entire sandbox mode. This thing now, which is kind of crazy to try to drive first-person mode, but it's kind of interesting as well. But yeah, Pre-Alpha 4 is going to be very different in the sense that, like, I have most of the like boilerplate systems in place. I can really just start focusing more on content. And of course that thing is going to be released next year. Oh, I got through the thing, but then I fell down. However, Pre-Alpha 3 is going to launch with mod support for the first time. So you're gonna get a few of the tools, not all of them. You're gonna get a few of the tools that you need to start making mods for this thing. It also means that I'm gonna start releasing these SDKs for you. So if you want to do, for example, what we've done today, you can definitely do that with the stuff that is coming with pre-alpha 3. And that's kind of fun, I guess. Of course, we have just like a whole bunch of mod content on screen right now. Like this first-person controller is obviously coming from a mod, but this level is also coming from a mod. And last but not least, this whole jetpack mechanic is coming from a mod. And none of it is actually in any way planned for in the main game codes. If anything, I'm starting to get pretty happy with the fact that this is so expandable, this game these days. That's very nice. That part is really coming together pretty nicely, and I'm hoping that the Steam Workshop support will make it even more usable. They could just click a button in Steam and then all of a sudden you have a mod in the game. That should be fun. But anyway, I think that's all for today. So I don't even know what to say anymore. Thanks to everyone who came to hang out today. It's been a long week again, and my brain is clearly fried. If you want to help out the project, do check out the Steam page for Traction Point. You can see the link to that in the chat. And you can also see it in the description below. If you want to play these pre-alphas, do join the Discord server. Or if you just want to follow the development on a more intimate basis, then come join us on the Discord. And that's also the easiest way to reach me if you have any questions or anything like that. Of course, all the YouTube jazz, like, subscribe, press all the buttons, press all the bells, whatever they have these days. Yeah, thanks, Jake. Thanks for reminding me. I did get to it eventually. We'll see. Maybe I'll do another stream, perhaps during the weekend or perhaps next week. Kind of getting back into the habit of making these ones, and it's pretty good. Hoping to continue doing that, but it depends on the work and how it's going, and if I have something that it's fun to watch, fun to stream. So we'll see. Anyway, have an excellent weekend, everyone. Thanks for hanging out today. See you next time.